Hello students, how are you? I am fine. Today we'll discuss the properties of oxides and halides of oxygen family. In the last class we discussed regarding the physical properties of elements of oxygen family, that is group 16, and the properties of hydrides. Now we'll discuss some properties of halides and oxides. We know generally halides, they produce monohalides like this M2X2, tetrahalides MX4, hexahalides, that is MX6. Generally these three types of halides are produced. Out of this, it is more stable. MX6 is more stable due to that covering of halogens, more electronegative halogen around the central atom. It results more stability. If you see these, they are mainly MX4. These halides, this type of halides, MX4 is seesaw structure, and that is sp3 dehybridation, and this type of halides octahedral structure, and hybridization is sp3d2. If you see sulfur tetrafluorides and sulfur hexafluorides, if you compare these two, sulfur tetrafluorides and hexafluorides, sulfur tetrafluorides contain one lone pair and sulfur hexafluoride has no lone pair. This fluorine fluoride, 6 fluoride atoms covering the sulfur atom. So sulfur atom is sterically protected by 6 fluoride atoms. That's why it is more stable. SF6 is more stable, inert behavior, and that is inert properties, SF6, and structure is octahedral structure, and it cannot be hydrolyzed because water molecule cannot enter to the sulfur atom because the 6 fluoride atom covering the sulfur atoms. That's why it is chemically inert and more stable. This, and SF4 can be easily hydrolyzed because due to absence of vacant orbital, and this, it has seesaw structure, more reactive than SF6. So these are some properties of halides of sulfur, and if you see the reactivity, that fluorides more active than chlorine, then bromine, then iodide. You see, this is fluoride compounds more active than chloride, then bromide, then iodide. So this is the some reactivity of halides. Similarly, if you see the oxides, they produce MO2, MO3, that means dioxide and trioxide. So they produce oxides and dioxides and trioxides. Dioxides generally they have bent shape, and trioxides, if you do planar. in gaseous state. In gaseous state, if you see, the molecule is planar, here molecule is bent due to presence of lone pair, and it has no lone pair, so it is planar. And if you see, these oxides are more acidic. It is more acidic. And here also, I have forgot to tell this thing. SF4 can be acts as oxidizing and reducing agent, both oxidizing agent and reducing agent. Because it is in which state? +4 state. It can be converted to +6 state. So it is your +1 state, like this. So this, as it is in +4 state, it can be oxidized to +6 or can be reduced to lower state. That's why it can be acts as what? Oxidizing agent and reducing agent. But SF6, if it is always used as reducing agent. It is always oxidizing agent. Always oxidizing agent, because it is in higher oxidation state, so it can be reduced. Only reduction is possible for SF6. That's why SF6 can be oxidizing agent, and it acts as both oxidizing and reducing agent. And this fluoride is more reactive than chloride, than bromide, than iodide, reactivity order. So here dioxide is bent shape and trioxide is planar shape, and more acidic is MO3 because the oxidation state of M is +6. That's why more acidic. So these are regarding the nature of oxides, dioxides and trioxides. Now we'll discuss very important part of this chapter, that is preparation, properties and usage of ozone. Regarding ozone, ozone is O3. Generally it is called O3. What are the preparation of ozone? It is prepared by electric discharging of oxygen gas. When oxygen gas undergo electrically discharge, it produce O3. Due to this, oxygen gas gets dissociated into O, then O again O2 produce O3. And this case also exothermic. Del H is positive. Here the case is positive. And this ozone produced is thermodynamically unstable. It is unstable. Thermodynamically it is unstable, O3. It can dissociate into, in presence of light, it produce O2 plus O. So under heat it is exothermic. At high temperature it O3 gets dissociated into oxygen and atomic oxygen. That's why ozone acts as oxidizing agent, because it produces atomic oxygen. Then what are the properties? The properties, if you see, it is a gaseous, that the gas is pale blue gas, pale blue gas, but in liquid state it is blue liquid, but black violet solid. Black solid. That means if ozone taken in gaseous form, that is, its color is pale blue color, and it is blue liquid and black solid. If you change the states, and color also, if you smell, it characteristic smells, characteristics, smell, particular smell it has. But oxygen is colorless, but O3 is color. Another important thing is O3 is diamagnetic. Diamagnetic character. O3 is diamagnetic, but O2 is paramagnetic. Oxygen is paramagnetic, but O3 is diamagnetic. If you draw the structure of O3, it is like this. So it is minus state, it is plus state, and it can undergo resonance like this. Okay, so this is the structure of resonance structure of O3. So what are the chemical properties of ozone? Already discussed chemical properties. Chemical properties already I have told you, it acts as oxidizing agent due to formation of what? Atomic oxygen from O3. What are the chemical property? What are the oxidizing agent? It oxidizes I minus and ozone and water to convert to I2 plus oxygen. I2 plus oxygen. If you balance, it will be in hydroxide form. That means if you take any iodide, potassium iodide or sodium iodide, it gets oxidized by ozone to iodine. I minus to I2 means loss of electron, that's why it is oxidized to iodine and itself convert to oxygen and OH minus. So you can balance it by different methods. So this is one step that I minus gets oxidized to iodine by ozone. What are the other step, other reaction? Other reaction is PBS gets oxidized by ozone to PbSO4. That means this color is black. Black color PBS color can be removed. That means decolorized. Black color can be decolorized by ozone because ozone oxidizes PBS to PbSO4. It is also one important oxidizing property of ozone is lead sulfide to lead sulfate, iodide to iodine. Ozone also, already I have told you, ozone also oxidizes mercury to mercury oxide. This is called tailing of mercury. This is called tailing of mercury. Tailing of mercury. Tailing of mercury means the convex shape of mercury will be disturbed. Convex shape of mercury will disturb when it will be contact with ozone. The convex shape of mercury will be disturbed when it come in contact with ozone. That's why it is called tailing of mercury. TAIL. Tailing of mercury. So these are some important oxidizing property of ozone. Then what are the uses? What are the uses of ozone? Ozone, as it has oxidizing property. It produces atomic oxygen when it undergo dissociation. So it is important role is oxidizing agent. As oxidizing agent. First property as oxidizing agent. In different chemical reaction, it can use as oxidizing agent. Second uses that due to this oxidizing property, it has a bleaching property, bleaching action. It bleaches oil, pepper, like this. Different substance can be bleach, starch, like this. So bleaching action, one important uses, it bleaches oil, pepper when required to decolorize the substance. Another important use is as disinfectant property. As a disinfectant and germicides. As germicides, you know that the swimming pool can be cleaned by passing ozone gas, because ozone has oxidizing property, produce atomic oxygen. So the microorganism produced in the swimming pool can be cleaned by passing ozone gas. This is also one important, the main important property is oxidizing behavior. As it produces atomic oxygen, so all these uses based on oxidizing property. So these are some important uses, properties, and preparation. It is prepared by electrically discharge. When it will be undergo electric discharge, then oxygen dissociated to atomic oxygen, the atomic oxygen, then oxygen combined to produce O3. And this process is endothermic process. And this O3 can be decomposed to again oxygen, but electrically discharging resulting formation of thermically stable. But this oxygen when will be applied, when will be given high temperature, then it will undergo dissociation, it will decompose to atomic oxygen and molecular oxygen. That's why this, you know that ozone depletion takes place at the upper layer, troposphere, due to the decomposition of ozone. Ozone generally produced in the upper layer due to ultraviolet light. The ultraviolet light absorbed by ozone and it produces atomic oxygen. And ozone is produced at the upper layer due to the electrical discharge, lightning. When lightning takes place, due to lightning, this oxygen convert to O3. Then O3 can be depleted. It undergo depletion, that is called ozone depletion, due to when it contact with some reactive oxides of nitrogen. What are these? Nitric oxide. These nitric oxides depletes ozone. And CFC, chlorofluorocarbon. These chlorofluorocarbon very reactive, it produce very reactive free radicals. These reactive free radicals undergo the decomposition of ozone, and NO also decomposes O3. If you write the reaction, NO, this NO produced from vehicles during combustion. So NO plus O3 undergo reaction, produce NO2 plus O, oxygen. Okay, and this you write also atomic oxygen. Then this atomic oxygen also produce during reaction of nitric oxide and O3. So nitric oxide also deplete ozone layer. This nitric oxide produced from exhaustion of the vehicles during combustion. Chlorofluorocarbon, this substance also deplete ozone layer. So these are some properties of ozone and its preparation and physical and chemical properties. Okay, thank you.